So let us discuss about the Carl Pearson's coefficient of correlation method here. Carl Pearson was the first person who gave the mathematical formula for measuring the degree of relationship between the two variables in 1890. So according to the Carl Pearson, coefficient of correlation is determined by dividing the sum of products of deviation from their respective means by their number of pairs and their standard deviation. For means Carl Pearson's coefficient of correlation is shown by, it is represented by R. R lies between plus 1 to minus 1. Magnitude of the direction means answers will come in between them. So the value of the correlation coefficient shall always be between plus 1 to minus 1. Then when the R is equals to plus 1, it means there is a perfect positive correlation. If when the R equals to minus 1, it shows that there exists perfect negative correlation between the two variables. If R equals to 0, it means there is no relationship between the two variables. That already we have discussed previously, but once more it will be there. So this is the formula given by him to find out their share the variability of the x and y variables on the top, individual variability of x and y variables on the bottom also is given here for your concern. So related to this, I will send the numericals to you. So interpreting the correlation coefficient are a strong correlation are greater than 0.7 or less than 0.7. Moderate, it is given here. Weak correlation is also given here. So the coefficient of determination is also given here. Coefficient of determination lies between 0 to 1, represented by R square, and the coefficient of determination is a measure of how well the regression line present the data. If the regression line passes exactly through the every point on the scatter plot, it would be able to explain all the variation. If the future line is always further line is away from the point, so less it will be able to explain here. So R square is useful because it gives the proportion of the variant of the one variable that is predictable from the other variable. So the coefficient of determination is the ratio of the explained variation of the total variation. The coefficient of determination is such as 0 greater than R square and 1 and denotes the strength of line association between x and y. I will send you the numericals of the step deviation method, direct method, or step method here. Now we can discuss before. I already told you Spearman ranking correlation is not in your syllabus. So now we will discuss about the coefficient merits and demerits of coefficient correlations and its assumption of the coefficient of correlation. So first of all, assumptions. So linear relationship, in this method, it is assumed that there is no linear relationship between the variables. That is, if the paired observation of both in variables are plotted on the scatter diagram, the plotted points will be formed the straight line. Causal relationship, there is no cause of and effect relationship between two variables. Under study, we have already discussed. Normal distribution, the two variables under studies are affected by the large number of independent causes of such a nature as to produce normal distribution. Variables such as height, weight, color of skin, commodity, price, demand, supply, etc. There are multiple forces for that. Error in measurement, the coefficient of correlation is more reliable if the error of the measurement is reduces in the minimum. Now we will discuss about the merits and demerits of the Carl Pearson's coefficient of correlation method. So what are the good qualities in that? It is the most popular and most widely used mathematical method of studying the correlation between the two variables, because in the mathematics already we know that the logics are used, and logically it will be proven that it is a very good method. Next is the correlation coefficient summarized in the one figure, not only the degree of correlation but also the direction, that is whether the correlation is positive or a negative. Now we can say that there are some limitations also there. What are the limitations? Affected by the extreme value. The value of the correlation are unduly affected by the value of extreme item. Time consuming method, it compares because the calculation is taking so much time. Assumption of the linear relationship, the correlation coefficient always assume linear relationship regardless of the fact whether that assumption is correct or not. Next is possibility of wrong interpretation. Very carefully we have to interpret the value of the coefficient of correlation. Otherwise it will be the answer is not coming properly and it is a misinterested. So these are the main things of the coefficient of correlations. Now I will send you the numericals of the coefficient this chapter.